Hi everyone, my name is Srishti Shah and I'm from Ajinkya D.Y. Patil University. I'm presenting presentation about process. So let's see what are the content. What is process? Process states, diagram of process state, operations on the process creation, process termination, process scheduling queue, cooperating process and reference. First is what is process? Process is a program under execution, for example, web browser, media player, etc. In computing, a process is the instance of a computer program that is being executed by one or many threads. It contains the program code and its activity. Depending on the operating system, a process may be made up of multiple threads of execution that execute instructions concurrently. Process states the process from its creation to completion passes through various states. The names of the states are not standardized, although the process may be in one of the following states during execution. First is new, a program which is going to be picked up by the operating system into the main memory is called a new process. Second is ready. Whenever a process is created, it directly enters in the ready state in which it waits for the CPU to be assigned. The operating system picks the new processes from the secondary memory and put all of them in the main memory. Third is running. One of the process from the ready state will be chosen by the operating system depending upon the scheduling algorithm. Hence, if we have only one CPU in our system, the number of running processes for a particular time will always be 1. If we have n number of processors in the system, then we have an n process running simultaneously. Fourth is block or wait. From the running state, a process can make the transition to the block or wait state, depending upon the scheduling algorithm or the intrinsic behavior of the process. When a process waits for a certain resource to be assigned or for the input from the user, then the operating system moves this process to the block or wait state and assigns the CPU to the other processes. Fifth is completion or termination. When a process finishes its execution, it comes in the termination state. All the context of the process control block will also be deleted. The process will be terminated by the operating system. Sixth is suspend ready. A process in the ready state which is moved to secondary memory from the main memory due to lack of resources, mainly primary memory, is called in the suspend ready state. Seventh is suspend wait. Instead of removing the process from the ready queue, it's better to remove the blocked process which is waiting for some resources in the main memory. Since it is already waiting for some resources to get available, hence it is better if it waits in the secondary memory and make room for the higher priority process. This is the diagram of process state. Operations on the process. First is creation. Once the process is created, it will be ready and come into the ready queue, main memory, and will be ready for the execution. Second is scheduling. Out of the many processes present in the ready queue, the operating system chooses one process and start executing it. Selecting the process which is to be executed next is known as scheduling. Execution. When the process is scheduled for the execution, the processor starts executing it. Process may come to the blocked or wait state during the execution, then in that case, the processor starts executing the other processes. Fourth is deletion or killing. Once the purpose of the process gets over, then the operating system will kill the process. Process creation. We know that whenever we execute a program, then a process is created and would be terminated after the completion of the execution. What if we need to create a process within the program and maybe wanted to schedule a different task for it? Can this be achieved? Yes, obviously, through the process creation. Of course, after the job is done, it would get terminated automatically, or you can terminate it as needed. Process creation is achieved through the fork system call. The created process is called the child process, and the process that initiated it, or the process when execution is started, is called the parent process. After the fork system call, now we have two processes, parent and child processes. How to differentiate them? Very simple. It is through their figure number two is process creation. Process termination. Processes will terminate usually due to one of the following conditions. First is normal exit. It is voluntary. Second is error exit. It is voluntary. Fatal error involuntary. And fourth is killed by another process involuntary. Most processes terminate because they have done their work. When a compiler has compiled the program given to it, the compiler executes a system call to tell the operating system that it is finished. This call is exit in Unix and exit process in Windows. The second reason for termination is an error caused by the process, often due to a program bug. Examples include exiting an illegal instruction referencing non-existent memory or dividing by zero. The third reason for termination is that the process discovers a fatal error. For example, if a user types the command to open a non-existing file, the compiler simply exits. The fourth reason a process might terminate is that a process executes a system call telling the operating system to kill some other process. In Unix, this call is kill. The corresponding Win32 function is terminate process. In both cases, the killer must have the necessary authorization to do in the killer. Process scheduling queue. Definition of this is the process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. The operating system maintains the following important process scheduling queues. Job queue. This queue keeps all the process in the system. Ready queue. This queue keeps a set of all process residing in main memory ready and waiting to execute. A new process is always put in this queue. Third is device queues. The processes which are blocked due to unavailability of an input-output device constitute this diagram of process scheduling queue. The operating system can use different policies to manage each queue, FIFO, round robin, priority, etc. The operating system scheduler determines how to move processes between the ready and run queues, which can only have one entry per processor core on the system. In the above diagram, it has been merged with the CPU. Cooperating processes. Cooperating processes are those that can affect or affected by other processes running on the system. Cooperating processes may share data with each other. Reasons for needing cooperating processes. There are be many reasons for the requirement of cooperating processes. Some of these are given as follows. First is modularity. Modularity involves dividing complicated tasks into smaller subtasks. These subtasks can completed by different cooperating processes. This leads to faster and more efficient completion of the required task. Information sharing. Sharing of information between multiple processes can be accomplished using cooperating processes. This may include access to the same files. A mechanism is required so that the process can access the files in parallel to each other. Third is convenience. There are many tasks that a user needs to do, such as compiling, printing, editing, etc. It is convenient if this task can be managed by cooperating processes.
These are the references. Thank you.